Hi, and welcome to this next video on integration from the Year 2 part of the course. And we're still cracking through some integration by parts. And in this particular video, what I'm going to do is just go through an exam style question. And I've devoted an entire video to this one because it's an absolute cracker. There's a lot going on. I mean, it is essentially same as you saw maybe in Year 1. It's kind of area under the curve. It's a bit of coordinate geometry. It's a bit about finding intersections of lines, but it's just done in a very, very technical Year 2 way, just with harder stuff. So the underlying principles are no different from what you've seen in Year 1, but like I say, it's just done with harder functions. And here it is. So what we've got to do is we've got to find the area under the curve and the line. So we've got the curve C, and we're given the equation of curve C, which is y equals x ln x. There it is. And what we've got is the normal to the curve. That's our line L. That's that thing there. So we've got to find the equation of that, and we've got to use those two things to work out this region down here, R. So there's a lot going on, and we're told the result says show the exact area of R is A times by E squared plus B, where A and B are rational numbers. And by rational, what we're talking about is fractions. So here we go. Let's crack on, and first of all, let's have a think about how we're going to deal with that particular area. So the region R, what we've got to do is split this up. So I'm going to split this into a triangle, which is underneath our normal, and then that's that bit there, and then the area under the curve, which is that bit there. So we've got my kind of red hashed area here, that's my triangle, and then I've got this bit under the curve here. So let's have a look at what's going on with that triangle, and let's think about what we know. So there's my triangle. And if I was in an exam, I would still be drawing it out exactly like this because I'm quite a visual person. Life, I think, is much easier than just see what's going on. I always say to my students, do all your thinking on the paper and not in your head, so you can see what's going on. We've got those 2 points, x1 and x2, that form the base of our triangle. And clearly x1, that's fairly straightforward. It's just the x coordinate here, so we know that's E. Clearly, we've got to find x2. And that will be the point where that straight line hits the x-axis. So we're going to need the equation of the line. So the first thing we're going to have to do is we're going to have to find the equation of L. And so off we go. Equation of L, we're going to need to do some differentiating. So we're going to need the gradient of the curve, C. So let's do that. So let's do some differentiating. So we're going to do product rule. So we've got leave the x alone, differentiate ln x. And then the second part would be differentiate x and leave the ln x alone. There it is. So we've got that result there. That's nice and straightforward. So now what we've got to do is say, well, what's the gradient at point P? Well, that's when the x coordinate is E, so let's sub that in. So at that point we've got 1 plus ln E, and ln E hopefully we know is 1. So that gives me a gradient of 2. So that is the gradient of the curve, so that's that bit going there. We need the gradient of the normal, so we're going to need to use m1, m2 equals minus 1. So the gradient of the normal is going to be minus a half. Okay, so we've got that. We also know we've got the coordinates of our point. So let's go y minus y1 equals mx minus x1. And there we go. So we've got y minus e equals minus half x minus e. And the point we're interested in, x2, that's when the y coordinate is 0. So let's put y equals 0 into here. There we go. And now we've just got a bit of rearranging, make that say x equals, so I can get rid of the minuses, because I've got a minus on both sides. Times out by 2, move the e over. Long story short, we end up with x equals 3e. So there we go. So now what we've got is we've got the 2 points that form the base of my triangle. So that one there is at e, this one is 3e. So therefore, if I want to find the area of that triangle, I've got half base times height, and I've got my base and height there. So it becomes that. So the area of that triangle there is simply e squared. And that fills me with a bit of confidence because I know the result I'm looking for has got e squared in it. So I'm reasonably happy when I see that start to appear. Okay. Next bit we've got to do is the area under the curve. So that's that section there. And this is the bit where we're going to need to do some integrating. So this is the bit where we're going to need our integration by part. But before we can make a start on that, you can see from the diagram we know that limit there, our upper limit is going to be e. We're going to need to work out what's our lower limit, so we need that one there. I've called it x3. So what's that lower limit? That's where the curve goes through the x-axis. So again, what we're going to have to do is do a bit of solving this. Let's go to our equation of the curve. That's this one up here. Stick it equal to 0. So we've got from there x equals 0 or ln x equals 0. Well, that one, ln x equals, sorry, when x equals 0, you can see is there. So that's not the one we want. We want the solution coming from here. And that will be when x equals 1. So there we go. So now that is our value there. We've got our limits. So here we go with our integration. So we're integrating x ln x within those limits. And if you remember from a previous video when I said when you're integrating with a ln, the choice of which one to use, which one to which one to use as u, which one to use as v changes. And what we're going to do is we're going to select ln x to be our value for u. So if we get u equals ln x, du dx is 1 over x. That gives us dv dx equals x. And so integrate that to get v. That gives us half x squared. So now off we can go. We can do our product. So there it is. So let's just remind ourselves. So we've got u times v, which is half x squared times by ln x, u times v, minus the integral. We've got half x squared. That's my v. And there's my du dx. And a bit of simplifying here. The x squared cancels against the x. So that leaves us with just x inside the integral. And as ever, I've taken the half. We've taken that outside the integral just to tidy that up. So now I've got a very simple integration to do here. And so we've got my half x squared ln x from this bit at the front here. Integrate x. I'm going to get half x squared. Times that by that half. That's where the quarter is coming from. So there we go. So that's the integrating done. What I've got to do now is substitute in my limits and demonstrate the intention to subtract. So here we go. Let's put in those two bits. So there we go. Sub in e. And there's our subtraction when we sub in 1. Hopefully we're happy that if I put a 1 into here, ln 1 is 0. And then tidy all that up a bit. And there we go. There's my area of my bit under the curve. Last thing, therefore, I've got to do is to put together my two bits. So what we've got, my total area is going to be my area under the curve, the quarter e squared plus a quarter. Add on the area of the triangle. So that's add on e squared. So a quarter e squared plus 1 e squared, that's 5 over 4 e squared plus a quarter, and there it is. And we're checking, yes, we've got it in the format we want, a rational amount of e squared, the rational number being 5 over 4, plus my rational constant, that's the quarter. And there we go, jobs are good.